We've all been there. The first bite of a hot noodle soup is perfect, but by the time you reach the bottom, you're fishing out bloated, mushy strands. As soon as a noodle hits hot broth, a timer starts. Over the next 10 minutes, it swells, softens, and structural failure sets in. The physics here are highly predictable. Starch sitting in hot liquid is continuously cooking. The heat expands the noodle's internal structure. Water rushes in, and that rigid, lattice-like starch matrix gets completely dismantled. To actually stop that ticking clock, you have to eliminate the two variables causing the degradation: heat and constant liquid immersion. This is a mechanical hack designed to do exactly that. It's called Tsukemen. Serving the noodles and soup in two completely separate bowls is a highly deliberate physical intervention. It stops the ingredients from destroying each other before you can eat them. Let's look at the top bowl. The most obvious engineering choice is what's missing. There is zero liquid. Instead, we have these incredibly thick, pale strands of noodles, and they are served completely cold. Resting right on top of them, completely dry, are the toppings. You've got roasted chicken, bamboo shoots, and wood ear mushrooms. To get the noodles like this, the chef uses a technique called shocking. Right after boiling, they are immediately plunged into ice water. That sudden drop in temperature causes the expanded starch network to contract. It snaps shut, locking into a dense grid known as koshi. This gives the noodle a highly resilient, chewy texture that would quickly melt away if left sitting in hot soup. Keeping the meat and vegetables out of the liquid accomplishes the exact same thing. It preserves the sharp crunch of the bamboo and the snap of the mushrooms. Bowl 1 operates as a secure, isolated environment built entirely to maximize physical resistance and texture. But separating the ingredients introduces a new mechanical problem. If you dip a thick, cold noodle into a standard bowl of ramen broth, the thin liquid will slide right off. That brings us to the bottom bowl. Look at the dipping broth. It's incredibly dark, heavily opaque, and loaded with floating particulates like scallions and chili flakes. This cannot be a standard soup. It has to be a hyper-concentrated, highly viscous reduction. The physics of viscosity take over here. This thick liquid acts as a flavor payload, engineered to physically grip the smooth, cold surface of the noodle the moment it's pulled upward. Because the noodle itself is essentially an unseasoned mass of carbohydrates, this broth carries extreme levels of salt and umami to balance out the bite. The intense, borderline overpowering density you see in Bowl 2 is a calculated, necessary reaction to the extreme cold and thickness of Bowl 1. To eat tsukemen, you execute a rapid, 1-second dip of the cold noodles straight into the hot broth, followed by an immediate slurp. This creates a massive sensory contrast in the mouth. You get the icy, dense chew of the noodle immediately clashing against a flashbang of hot, salty liquid. If you were to permanently combine these hyper-chewy noodles and this hyper-salty broth in a single bowl, the dish would be completely unbalanced and virtually inedible. Pushing these variables to their absolute culinary limits is only possible because of the physical barrier of serving them in two separate bowls. You see this same structural trick in other foods, like a deconstructed dessert or a layered cocktail, where keeping the components separated prevents them from neutralizing each other. When confronted with a deconstructed dish, look past the plating. The deliberate isolation of variables